Okay, so we're going to talk about two very special right triangles today. And for the first one, I have a way to discover, I guess, the theorem. But the second one, I'm pretty sad. I'm not going to get into it. You guys should be, it should be bittersweet for you. Okay, so let's talk about Theorem 8.6. So Theorem 8.6 states that if we have a right triangle that specifically has two 45-degree angles, which if you turned this around, it would actually be an isosceles triangle, correct? Because the bases are the same, therefore the sides are the same. So let's use what we already have done, which is a squared plus b squared equals c squared to find this third side. So I know that this side has to be congruent with this side. So it doesn't matter which one's A and which one's B? No. So I'm just going to substitute in, if I have the side n and I square it, and I add that to the other side n and I square it, I should be able to find the hypotenuse of this triangle. How many n squares do I have?
4.
I have 2. I have 2 n squares. What do I normally do when I have squares on both sides and I'm trying to solve? I do the inverse, which is take the square root. Okay, so 2 isn't a square, but n squared is, so I get to send the n outside of the square root, correct? Because they're inverses. So n times the square root of 2 equals c. So in fact, whenever you have two sides of a right triangle that are the same, I know that the hypotenuse is larger by root 2. Okay, so let's look at this first problem. So just like in the last problem, or the last example, when we were looking at the theorem, what did we say? We said that the hypotenuse, which is RS, is how much bigger? It's bigger by root 2. So if I were to multiply the side times root 2, that would give me the hypotenuse, correct? Well, I know what the hypotenuse is. What is the hypotenuse? 8. So the leg times root 2 should equal the hypotenuse, correct? If it's the same size, yes, it'll always be larger by root 2. Okay? So if it's a 45, 45, 90, it's always going to be larger by root 2. So how do I solve for this? How do I solve for A? Do what? Not exactly. Pretend like this was A times X, and I was trying to solve for X, or solve for A. What would I do? I would divide. Divide by root 2. When I do that, my root 2's cancel over here, and I get 8 divided by root 2 equals A. Can't yet, because this is a root. I can't have a square root in the denominator. So how do I fix that? You wouldn't want to square both sides, but we're getting close. We need to rationalize the denominator. How do you rationalize the denominator? You multiply by root 2 over root 2. Change that color. What property tells me I can multiply by root 2 over root 2 on just one side of an equation? What property tells me I can multiply by 2 over 2? What is 2 over 2? 1. So doesn't that mean that root 2 over root 2 is also 1? What property tells me I can multiply anything by 1 and still have the same answer? No. Pedro? Identity. Good job. Okay, so when I do this, I get, let's do our work over here. Do the work for this over here. So when I multiply this across, I get 8 rad 2 over rad 2 times rad 2, correct? Which equals 8 rad 2 over, yes, I'm just not skipping steps. Everybody follow me so far? Which equals 8 root 2 over 2, which equals 4 times 2 root 2 over 2, which equals 4 rad 2. Just a long way of doing it. I just want to make sure that you got every single step of that. Yes. So let's go back and look at this. A equals 4 root 2, and A equals 4 root 2. And if I were to put this in the Pythagorean theorem, I would square this and square this, add them together, and I should get 8. Right? Okay, so let's look at the second theorem we have. We have theorem 8.7, which says if I have a right triangle that's a 60, 30, 90 triangle, then I have, first of all, n is the shortest side. How do I know n is the shortest side?
With the base.
Hold on. Melanie, explain. It's across from the smaller angle. Remember that? The inequality theorems that we learned? 30 degrees is smaller than 60 degrees. Well, the side opposite the smaller angle is the smaller side, right? So this is the smaller leg of the triangle. Okay, so the first part says that the hypotenuse is 2 times larger than the shorter leg. So it would be what? What would be the hypotenuse? 2n. And the longer leg is root 3 times longer. I should say. Longer than the shorter leg. So what would make that one? N times what? Square root of 3. This is 2 times n. I always think of n and 30. You're not adding, you're multiplying. Since 60 is twice as much as 30, that's how I remember that this side is 2n. And then this side, I always say, is n times root Let me rewrite. That's how I remember it, James. You see what I'm doing? This side is n times root 3. And of course there's a proof, but do we want to go there right now? No, I didn't think so. No. Okay, so let's find QR. I'm going to give you a second to write this down. Okay, so in order to find QR, QR is right here. We know QR is the hypotenuse because the right angle is pointing at it. So QR is what? How much times bigger than the smaller of the two sides? This has to be the smaller side because it's opposite the smaller angle. How much bigger is the hypotenuse? The hypotenuse? 2 times larger than the smaller side. I can't really simplify this anymore, right? So QR is 8 root 3 over 3. 8 root 3 over 3. Because 2 over 1 see it? Good question. Multiply straight across. All right, it didn't ask us for PR, but how much larger is PR? Not by 2, by root 3. So in order to find PR, I could just do root 3 times 4 root 3 over 3, which makes 4 root 3 root 3 over 3, which makes 4 times 3 over 3, which makes 4. Everybody see how I did that?
No.
Root 3 times root 3 would make root 3 squared.
Oh, yeah.
Right, which is 3. Then cancel, cancel, which is 4. Yep. Same thing.
I'm just wondering why you do the 2, like how you know it's like 2 times 2 is kind of better with 3. Never with 3.
Okay, forget there's anything. If I just said 2 times times 4 times the square root of 3, wouldn't that just be 8 root 3?
Yeah.
That's what I did.
So how would you know though if you did that one? How would you know it'd be 2 or
You guys, okay, so here's our last example. It gives us that x is at negative 2, 7. Just pay attention. It also gives us that y is at negative 7, 7. With that doing I don't need to use the distance formula to figure out how far it is to get from here to here. To go from here to here, it's 5. Right? So then I need to figure out, it already told me that this is a 30, 60, 90. It already tells me that this is the shorter leg. So if this is the shorter leg, how much longer is this side than this side? 5 root 3. So in order to find this point down here, I would just have to start at 7 and go down 5 root 3. I already know what my x-coordinate is. What would my x-coordinate be? Negative 2. Then I would start at 7 and I would go down by 5 root 3. And there's my answer. Have a great day, guys.
Well, that's all I knew of my tutor today, the first time.